We all have heard the word virus, from the common flu in winter season to electronic viruses in computers, laptops, or even smartphones. Right now, if you make an internet search, you will find the infamous coronavirus. The name of the virus comes from severe acute respiratory syndrome. Hundreds of researchers around the world are trying to find a cure to this pandemic. Just as a quick reminder, everything began in the 2019, when in December, the Wuhan Municipal Health Commission in China reported a cluster of cases of pneumonia. With the passing months, the effects of the virus became spread worldwide. According to the World Health Organization, in the year 2020, COVID-19 caused more than 80 million cases of infections worldwide, with nearly 1.8 million deaths. COVID-19 brought enormous socioeconomic consequences, alongside many new guidelines and rules to find a new normality. This is the bad side of the virus. But not all the viruses are villains. Some viruses can kill bacteria, while others can fight against more dangerous viruses. Alongside the helpful bacteria in the human gut known as probiotics, we also have several protective viruses in our body. Bacteriophages are a type of virus that infect and destroy specific bacteria. The phages present in the mucus are part of our natural immune system, protecting the human body from invading bacteria. Pagivirus C is a virus that does not cause clinical symptoms. Multiple studies have shown HIV patients infected with Pagivirus C live longer in comparison to patients without it. Noroviruses were shown to protect the gut of mice when they were given antibiotics. The protective gut bacteria that were killed by the antibiotics made the mice susceptible to gut infections. But in the absence of good bacteria, these noroviruses were able to protect their hosts.
As you may know, nowadays with the COVID-19 pandemic, most people are afraid of the viruses, but at the same time, the frustration is becoming notorious in several countries. COVID-19 have brought a huge impact in worldwide travel, economy, and physical and mental health, as we can see. That's why I want to interview expert researchers to give a better perspective of viruses to the audience. Let's start with our first question. What are your thoughts about genetically engineered viruses or modified? Is this a reality? Which are the application of these modified viruses?
In terms of genetic engineering, we can now manipulate the genomes of viruses in a relatively straightforward manner. So advances in the last 10 to 15 years have been great and given us new tools that we can use to change the genetic makeup of viruses. And while that might sound a bit kind of Frankenstein and a bit scary, actually what we're doing is, or what research is doing, is firstly trying to understand how the viruses work. So by modifying them slightly, you can study them in different detail, but also we're using them as tools effectively to help us achieve other benefits medically in humans, but also in the veterinary field in animals as well. And probably the best example I can think of when we think about genetically modified viruses bringing us a benefit, goes back to COVID-19 actually. And the AstraZeneca vaccine that a lot of us are getting access to now, that vaccine is a genetically modified virus called an adenovirus. And what the scientists have done is they've taken the adenovirus, which is a virus that generally doesn't cause disease in humans, and they've changed its genetic makeup slightly to take out some genes that by taking them out, the virus now can't spread around the body and replicate and make copies of itself. And they've replaced those adenovirus genes with a gene from SARS-CoV-2, the virus that causes COVID-19. So when that gets injected into your arm, then the virus looks like an adenovirus. It infects cells. The genetic material of the adenovirus goes into your cells. It doesn't combine with them in any way. It kind of just floats around inside the cell and starts to make, or encourage the cell to make, protein. And one of the proteins that the cell starts to make is this spike protein from SARS-CoV-2. And because it's an adenovirus, the body recognizes that it's being infected, but because the adenovirus vaccine is genetically modified, it's not able to cause disease, it's not able to make copies of itself. It effectively just initially infects a small number of cells in and around the bite site predominantly, or not bite site, sorry, injection site predominantly, and encourages those cells to make the spike protein.
So we don't find many examples like this because we're not looking for them, but we have intimate relationships with viruses, and sometimes they're positive, and generally the ones we know about are more negative. So you asked me about engineering viruses, and you know, I'm a molecular virologist. That's what I do. I make mutations and see what happens. And yes, we can do that to understand how viruses change. You know, I'm thinking about how the SARS coronavirus 2 is changing, and we're getting these variants of concern. And in other viruses, similarly, we can study mutations by engineering them into viruses and better understanding the disease. But we can also use that bioengineering to turn viruses into tools for our benefits. Another fantastic example about how viruses are engineered is to treat cancer. And there are a couple of licensed products now where viruses have been engineered so that they only infect cancer cells. When we have cancer cells have various different cellular mistakes in them. That's what makes them a cancer cell. So they grow and they proliferate in an uncontrolled manner. And viruses can take advantage of that and only replicate in those cancer cells that are replicating and proliferating like crazy. So the virus ignores the healthy cells and just infects the tumor. That then triggers the immune response, which has been ignoring the tumor, and alerts the immune response that there's something wrong in this particular part of the body. And then the immune response targets the tumor as well. And both of those things can be really powerful ways of treating certain cancers. And some of those have been licensed over the last few years. So viruses are horrific.
Now that we have clarified that we can modify these viruses, what is your opinion about how can viruses affect our future? It is possible that they can be used for medicine, for the creation of better therapies, or application in agriculture or veterinary to protect crops and animals for certain diseases.
One really high potential area for treatment is the use of bacteriophage. So growing in the laboratory these viruses that are very specifically able to attack and kill bacteria, such that these bacteriophage could be used as a treatment. So if you were infected with a bacteria that was causing a disease, you could, instead of using an antibiotic, because maybe the bacteria is resistant to that antibiotic, you would use bacteriophage, and the bacteriophage would target and kill the bacteria and stop it causing disease. And there are some really nice examples already of that being used in the US, for example.
It is possible that the mutations in the virus strains that we have seen currently all over the world have a direct relationship to the environmental changes, or are they related to the movement of people around the world during the pandemic?
In general, viruses, particularly like the coronaviruses that have an RNA genome, when they're replicating, they're pretty messy at replicating that genome. And just by random chance, mutations get put in. And if those mutations have a benefit and make the virus replicate better or transmit better, then it's survival of the fittest. Those are the virus particles that are going to be transmitted to other people. So we're seeing variation in these viruses because there's lots of chance, there's lots of opportunities for the virus to change, to replicate and mutate. So one of the critical things when we're thinking about using vaccines to reduce transmission is that it's so vital to keep up with all of the other ways that we reduce transmission. Because if you have lots of vaccination and high levels of virus transmission, you're potentially increasing the chance that you're creating an environment that will force viruses to evolve, to mutate and change. so that the vaccines aren't as effective. So we're seeing mutations because we're seeing lots of transmission of the virus. And of course, those viruses then get carried to different countries as people fly and move around from one country to another. So there is a potential for variants of concern to arise in any country where there's high levels of virus activity and transmission. And then it's a case of, well, if borders are open, then people can carry those variants of concern into other countries. And that's the difficulty. So it's a bit of a combination of our behavior, letting transmission take place, the movement of people around the world, and also giving the virus the opportunity to replicate and make mistakes. And any of those mistakes that make the virus fitter, they're going to be the ones that take off and spread from person to person.
The COVID-19 is not the first pandemic of humanity, and nor is going to be the last one. So could you please advise us on how can we find the priorities for prepare better for the future, or even how can we prevent another pandemic in the near future?
You're absolutely right. This isn't the first pandemic we've seen. Spanish flu, I suppose, the one that jumps out at people, but there have been multiple pandemics that have killed millions of people through, millennia. And SARS-CoV-2, COVID-19 is just the latest one that we're dealing with. Now it's very much expanded on an extreme scale. But there's no doubt that these kinds of pandemics, and potentially with even greater impact than what we're experiencing at the moment, could be in our futures. Now, it's impossible really to predict when they will occur, but it's really a question of when rather than if, because there's no doubt that new and emerging viruses have the potential to cause pandemics in the future. And really what we need to do as a society is recognize and acknowledge that this is not the only pandemic we're going to deal with, that more pandemics will potentially arise. And so we need to figure out ways to protect ourselves more effectively against those. And that's really has to be targeted at researching on a fundamental level how viruses work, how they cause disease, because although we've been working on these things for, nigh on 50 odd years, we're still learning a huge amount every day about how viruses work and how they cause disease. So we need to do that on a fundamental level and broaden our scope to understanding all viruses that are potentially out there. And then secondly, we need to be prepared and surveil areas of the world where these guys might come from.
So I really wish going forwards, we learn from this experience and we don't forget about it, and we can build resilience into society, not just Irish society, but also global society, so that we can respond faster and more effective to whatever the next pandemic is. There are so many lessons that we could have learned, and we could have put in different measures faster if we'd been thinking a bit more about the influenza pandemic. Now, that's not to say that this SARS coronavirus 2 behaves in the same way as influenza. It doesn't. But a lot of the same methods of reducing transmission hold up for both of those viruses. So I hope, looking into the future, that we learn from this experience, and that more funding is put into public health and building up public health resources, so that testing and tracing and complex outbreak investigation can be done faster and more efficiently and effectively. There's obviously, it's important to understand the different types of threats that are out there in the world. So that means going out and looking at the different viruses that are in different environments, and having good surveillance systems, warning systems for when something unusual happens. And those exist, and they've been used really, really effectively over the last couple of decades to warn people about the first SARS outbreak, avian influenza outbreaks, Ebola outbreaks. So we have a lot of tools. We just need to keep on building them so that we can identify spillover events when viruses move into the human population. Because one of the things that's important to remember is a lot of these viruses, where we've never seen them before, they come from animals. And as we are exposed to wild animals, and habitats change, and climate change means that you have mosquitoes increasing their territories, all of those things increase the likelihood that humans are going to have interactions with these mosquito viruses, animal viruses. And sometimes if the right conditions or the wrong conditions come together, that then means that a virus can jump from the animal into people and potentially cause an outbreak.
In the end, I want to highlight that not everything is black or white. We need to find reliable sources of information with specialized groups of researchers and experts, not only scientifically, also socially and economically. That will help us see the whole picture and understand that even viruses can have a good side and bring benefits to the humanity.